looking at section 13.3, and we're going to talk about arc length in space. So for arc length in space, we are talking about the length of the vector. And when we think about vectors, we think about magnitude. So we're thinking about the magnitude of the vector. When we think about the length, we're thinking about kind of tracing it out with a string. So taking our number line, but having it be a curvy number line. And then when we straighten it out, how long would that number line be? As we've talked about length before, length is like Pythagorean theorem. And in Pythagorean theorem, we have a change in x. Well, in calculus, we can think of change in x as a derivative in the x direction. So change in x squared and the change in y squared, the derivative in the y squared, and then that would give us the hypotenuse squared. We're doing lots of those, lots of little ones, lots of little Pythagorean theorems, so then we're going to add them up. So that's what that integral does for us, is add them up. But then now we're in space, so we also have the z direction. So we take the derivatives of each of them, square it, and when we square root it, that gives us then the length of any one of those sections, and then integrate to find the full length. So the arc length formula is then really finding the magnitude, or the length of the velocity vector. We've looked at this helix a few times, so think about the helix. If we want to know the length of the helix, could be a good manufacturing thing, right? So, it doesn't start as a spring. It starts as, just a long piece of metal that needs to coil. How long does that piece of metal need to be to create that coil? So here we're talking about a directed distance from any point. So how far is it from one point to another point on there? We're not going to worry about that tau. So here, this unit tangent, though, your assignments will ask you to find our unit tangent vector. Our unit tangent vector is found by dividing the v vector, the velocity vector, by its length, which is the magnitude. So we take the velocity vector, divide it by its length, that gives us a unit vector. And because we're going from position to velocity, we're thinking about tangents. So this is our unit tangent vector. It has a length of 1, and it is tangent to the position. So that's where the heart of your assignment is going to be, is finding this unit tangent vector, which we're going to call t, and then also finding length, which you have to do to find this. So, all right. So let's go into an example of that. It's going to be a pretty short lesson, and it's actually your last lesson. This is the last calculus lesson of the semester, so kind of crazy that we're here already. So example, R is cosine of ti plus sine of t j plus tk. And we're going to be working with time from 0 to pi. So if we want to find that unit tangent vector, so that's what your homework assignment is going to ask you to do, is find that unit tangent vector and then find the length. So the unit tangent vector, we need to find v. If we have r, then v is r prime, right? So velocity is the derivative of position. So we're going to take our derivative. Derivative of cosine is negative sine. Derivative of sine is cosine. And derivative of t is 1. So that would be our velocity. And then that unit tangent vector is v divided by the magnitude of v. Magnitude of v is not just make everything positive. Magnitude of v is length, so we're going to take the derivative of the I part squared, the j part squared, and the k part squared. Right? And then when we clean this up, we got sine squared, cosine squared, and 1. And then some more cleaning to do here. Sine squared plus cosine squared. Well, that hopefully is a familiar substitution. That's 1. So we get a square root of 2. That's the magnitude of this. So then that unit tangent vector is the velocity vector divided by the magnitude of velocity. So negative 1 over root 2 sine of ti. Take that, the v vector, and divide by a square root of 2. Plus 1 divided by the square root of 2, cosine of tj, plus 1 divided by a square root of 2, k. So that'd be our unit tangent vector. Then the other thing we want to do is find the length of the vector r. Okay, so length of r on the interval that was provided, the 0 to pi. Well, the formula for length was that we're going to integrate from a to b the square root of dx dt or df dt or whatever we want to call that first one, whatever direction, squared. I'll just leave it as x. And then dy dt squared and dz dt squared. And then that's all dt. So we're taking the derivatives of the x part, the y part, and the z part. Well, we already did that. We already took the derivatives of them because that's how we got from r to v. We took the derivatives. And then we want to square them and put it under a square root. Well, we already did that too. We already squared them and put it under a square root. So we know that this whole square them, put them under a square root thing is square root of 2. We already calculated that. We already found that. That's the length. That's the length of the vector, but of the velocity. So then to find the length of the position, we're going to go from 0 to pi. We already know that's square root of 2 dt. So now we just need to integrate a square root of 2. Well, when you integrate a constant, it just brings the variable into it. So we got the t there from pi to 0. So square root of 2 times pi minus square root of 2 times 0. And so run into my own little picture there. Come up here. We just get square root of 2 pi. That's the length of the position vector on the interval from 0 to pi. So see, there's some redundancy here in this, that when we find that magnitude of v, then we're really finding the length within that formula, and so we can just do a little substitution there, and it's a good time saver. Okay, so that's it. That's the only kind of problem you're going to have on your assignment is finding that unit tangent vector and finding length. And so that's not only it for this lesson, that's it for the year. So you're actually done with our study of Calculus 2. So as always, let me know what questions you have, and I'm happy to help as you wrap things up.